This is R.D. Sharma solution, class 12, chapter 19. We are taking exercise 19.26 of indefinite integrals. Now this is e raised x log x plus 1 by x square. Now you see, log x differentiation is 1 by x. It is not 1 by x square. So we have to devise a plan so that we can get this e raised x fx plus f dash x. This is the relationship which we are, or the result which we are following in this exercise. So this is directly equal to e raised x fx plus constant of integration. So we have to have a 1 by x. So we'll insert it and we'll try to separate this whole integral in such a way that we are able to apply this result. So I'm taking this log x plus 1 by x square. So this is log x, and since 1 by x we need to have, so I'm adding 1 by x and then I'm subtracting 1 by x because I have added, so I need to subtract also. Then we have 1 by x square. Now separate them out. E raised x is already following it, or it's preceding it actually. So log x plus 1 by x is one term we are making, and the other term will be like this, negative 1 by x plus 1 by x square, and then separate them out and multiply them by e raised x, and here also e raised x, and then we'll have a plus sign in between, and then we'll put this integration sign. Now this is an integral, exactly same. This is integral because we have done nothing, just we try to make it in a way so that we can apply that result. Log x plus 1 by x. Now you already know that we can apply directly this result. So this will form like this, e raised x fx plus constant of integration. So fx is log x, f dash x will be 1 by x. So e raised x log x plus constant of integration, that is the result of the first part. Now e raised x negative 1 by x plus 1 by x square. So if you take this negative 1 by x as some value and differentiate it, x raised minus 1, so this minus 1 will come in front, d by dx of negative 1 by x will be what? So it will be x raised minus 2, and minus is already there. So minus 1 x to the power negative 2, that will be the result. So minus minus will become plus, x raised minus 2 will go downstairs, it will be 1 by x square. So here also negative 1 by x can be considered as fx, and 1 by x square can be considered as f dash x. And when we add them and multiply it by e raised x, this will be an integral, and final result or actual result will be e raised x into fx. What is fx? Negative 1 by x. So now we need to add these two. So when we add this, the integral will be e raised x log x and negative e raised x by x also. This is coming from the second part I made. So just write e raised x 1 by x. And this constant of integration can be added, and this is constant of integration. Now you can take this e raised x outside, and this will be log x minus 1 by x plus constant of integration. So this is the integral. This is your final result. So this is the result I was talking about, and this is the way you are going to solve it. The main thing is to separate them out and insert 1 by x, and that will make this solution quite easier for you. Now this one e raised x, and we have a x in the denominator. So we need e raised x fx plus f dash x. If we are able to make this, then we will be able to solve it, because it is simply e raised x fx. So we need to identify fx and f dash x. But since x is already there in the denominator, how can we do that? So let's take this x in the denominator. That is, multiply this 1 by x inside. So x log x whole square is already there. We have x in the denominator plus 2 log x, and then we have a x in the denominator. Now x that you can cancel. So this fx will be log x whole square. If you take this fx as log x whole square, what will be f dash x? Because log x whole square, f dash x will be what? It will be 2 log x, and differentiation of log x will be 1 by x. So you have 2 log x by x, which is actually the second part. One is fx, one is f dash x. So e raised x fx will be the result. What is fx? We have taken log x whole square. So you can have log x, and this is log x whole square plus constant of integration. Now if somebody wants that this needs more explanation, so we'll just increase the step like that. So fx and f dash x is already there. So we'll take this e raised x fx as t. What is fx? We have devised a plan. We have devised two terms, and we know that fx is log x whole square. So we'll take it as t. Now we'll differentiate both the sides. When we differentiate, it will be e raised x log x whole square will be, I'm differentiating it right now, 2 log x. We have already done that, so I'm writing it directly, 2 log x divided by x. Now log x whole square will be like that only. E raised x will be differentiated, it will remain e raised x only, and this will be equal to dt by dx. Now let's do the rearrangement. E raised x I am taking outside, log x whole square as the first term, and then 2 log x divided by x as our second term, and dx we are bringing on the left, and on the right it is dt. So when we integrate this, when you integrate this, you don't have to integrate the left hand side because it is already original equation. This has come from the original equation only. I told you how I simplified it. So integration will be simply t plus c. So I am writing the answer here now. I will be equal to, what is t? T we assume to be e raised x log x whole square. So e raised x log x whole square. This you can just square it and plus a constant of integration. So from here to here is your final result. You could have stopped earlier also, but the thing is, if you need more explanation, then this whole solution has to be done. Only applying the formula will not get you to the proper position. Now this question, if you see, seems to be quite typical, but it is not. How? Just separate these two terms out. So I am making two terms out of one term which is after e raised x. So we have under root 1 minus x square sine inverse x and divided by under root 1 minus x square. And the second term will be below 1. So 1 divided by under root 1 minus x square. This gets cancelled. E raised x is already there, so you can add it anytime. And add the integration sign also. Integration e raised x sine inverse x plus 1 by under root 1 minus x square. So what do you see here? Sine inverse x has a direct result of 1 by under root 1 minus x square if it is differentiated. So it's directly f dash x. Fx is sine inverse x, so f dash x will be 1 by under root 1 minus x square. E raised x is here. So directly formula what we were thinking is right in front of you. So e raised fx plus c is the result. What is fx? It is sine inverse x. So e raised x sine inverse x plus c is the final result. Now if you need more explanation, if this question is in MCQ or in a 1 marks category, then it's okay. But how about making it more explanative? So we'll take e raised sine inverse x as t, because we know e raised x is followed by sine inverse x. That juncture I have already taken you to. So e raised x fx we have taken as sine inverse x. Now differentiate both the sides. So we have sine inverse x, in differentiation of e raised x will be e raised x only, plus now sine inverse x differentiation will be under root 1 minus x square. E raised x will remain like that, and on the right it will be dt by dx. Now both sides we are going to integrate. We'll take this e raised x outside and integrating. So e raised x I am taking outside. What remains inside is sine inverse x plus 1 by under root 1 minus x square. And dx will bring on the left. On the right it will be dt only. But what you see here on the left is just the original integral only. So you can just indicate it with I. On the right it will be simply t plus c. When you have this t, e raised x sine inverse x was taken as t. So I will be e raised x sine inverse x plus constant of integration. So how we are going to do this? This is the step-by-step explanation or the presentation of the result, which you need to follow when you are actually writing. Now e raised 2x negative sin x plus 2 cos x. If you take 2 cos x and you also have a e raised 2x, so first blockade is e raised 2x, because we need e raised x fx plus f dash x. That's what we want. So this will be simply e raised x fx. That is your result. Because we have already done 18 questions and you already know that this formula can be applied anytime. But e raised 2x is an issue. Either you can take this 2x as t and then you can reformulate this negative sin x plus 2 cos x. But what we will do here is e raised x cos x equals to t will take. This is just I have known by experience. So e raised 2x into cos x will be taken as t, and you see what are you going to get. So we'll differentiate both the sides. E raised 2x is already there. Cos x will be negative sin x, and cos x will remain like that. So it will be plus cos x, and then e raised 2x will be differentiated. So e raised 2x and 2x will be 2, and this will be equal to dt by dx. So this is the first step. We did differentiation, and then we'll do the integration. Now e raised 2x I can take outside. It will be negative sin x, and this will be 2 cos x because e raised 2x has been taken outside, and this is equal to dt by dx. So dx will go on the left, dt will remain on the right. Okay, what is this? This is I, and what is this? This is also I. This is the original integration. So I will be equal to, this is integration of dt will be t plus constant of integration. So this I will be, what is t? E raised 2x cos x. So e raised 2x and cos x plus constant of integration. So you can apply this formula whenever we have e raised x kind of thing, but there are certain points where you have to adopt different strategy. So this strategy which I told you is presented here also. You can follow this while writing and you can just practice it. 1 by log x minus 1 by log x whole square. So we have, this is e raised x is not there. We don't have e raised x here. So how to get this? But we know that log can be converted into e raised x, that is logarithmic and exponential values, or logarithm and exponential are almost similar, or they are faces of the same coin. So if you take log x equals to t, e raised x was not there, and log x, if you take t, and 1 by log x differentiation is negative 1 by log x whole square, that you know already. So we need to get e raised x also in order to apply the formula. So log base ex equals to t, because anything which is not being said, log will always have a base e. So log base a b equals to c, if you assume, is simply equals to a to the power c is equal to b. That is log base ex equals to t is e raised t equals to x. So a log base a b equals to c, that simply means b equals to a raised c. So x will be equal to e raised t. When you take x equals to e raised t, we need to differentiate it also. So when we differentiate dx by dt, this is equal to e raised t will be e raised t only. We are differentiating with respect to t. So e raised t will be there. So dx will be equal to e raised t into dt. So dt we have taken on the right upstairs. So log x was t. So now replacement will be done. This expression will become like this. Log x is t, so 1 by t. Log x whole square will become 1 by t square. This dx has to be replaced by things which are containing t. So dx has to be written as e raised t dt. So e raised t I am writing it here, and dt I am adding it at the last. Now you see 1 by t has a direct differentiation which gives you negative 1 by t square, because e raised x fx plus f dash x, you can have this f dash x, so fx plus f dash x e raised x will give you direct result which is e raised x fx. This will be e raised x fx plus constant of integration. Actually it's, if it is t, so you can call it as e raised t ft plus constant of integration. Alright. So e raised t ft plus constant of integration. So this ft is 1 by t, f dash t will be what? It will be negative 1 by t square. So we have a direct result applying opportunity here. So you can write e raised t and fx will be 1 by t, which we got from here. Now you need to replace t. T was introduced by us only. So e raised t is simply x and t is equal to log x. So e raised t is x and t will be written as log x, which we assumed earlier, plus constant of integration, and this is your final integral. Alright. And in order to understand more, you can just follow the scheme or the result, and this is the reference for those who are doing by themselves. And this we will take in the later part. So thank you so much. Have a good one.